So this is our Chapter 2 test review. Now what I'm expecting all of you to do is I'm expecting you to go to each problem that I'm working on, even if you did not have a question on it. So nobody's rustling around with anything else. Put away everything off your desk except for your chapter, your homework spiral. And not on your lap. That doesn't mean put something on your lap that you're looking at instead. Everything is put away except your chapter, your homework spiral with your chapter review in it. I can't imagine anything else that would need to be out right now. You have a marking pen in your hand and you are checking all of the work that goes with these even if you don't have a question on it. Okay, so this was from page 110 is what we started on. All right, so we asked, the first one you guys asked for was number 39. So 39 said you divide a stack of flyers for a craft into 6 smaller stacks for volunteers to distribute. The smaller stacks each smaller stack contains 15 flyers. What is the total number of flyers distributed? Okay, so as you're looking at these, you're taking note of all the information. First of all, they tell us that you divide a stack of flyers into 6 small stacks. All right, the next thing they tell us is that each stack, and I'm hoping all of you recognize this number, this type of number, each stack has 15 flyers. All right, what kind of number is that? Cullen? That's a rate. What information do I always use with a rate? Or what operation do I always use with a rate? Alex? Multiplication. What information do I always multiply a rate by? The denominator information, right? Yeah. So if I wrote this is number of flyers per stack. So if I wrote that, and I don't care how many are in the stack, I just care that it's a rate. A rate is always a part, and I always multiply it by my denominator information. You guys cool with me so far? Okay. So then it says, what are the total number of flyers? Okay. So I recognize you have divided into. Don't let that throw you off. Pay attention to your parts equal to your whole. Always take a look for a rate. All right, so when I look at my parts equal to my whole, I know my rate is one of my parts. So my number of flyers per stack times my number of stacks equals the total number of flyers. Remember, your units of your denominator go with what you multiply a rate by. The units of my numerator go with the units of my whole. These are the same information. Can you guys see that? So those rates are really helpful. They help us see what is the information of my whole. Okay? The denominator information tells us what the information is that we have to multiply that rate by. Yes? No, I did not say you could not have your X as your total. No, so I know that's, and I hear that all the time. You have to write parts equal to your whole. If your whole is what's missing, that is going to have to be your X. Yep, so the thing that I want to make sure you guys totally understand, your game plan is always parts equal to your whole. I don't care what's, I don't mean this, I don't care. Like, it doesn't matter what's missing. So I want you guys to get that, like, that's what I want to enforce in with you guys, or push in there in your heads. It doesn't matter what information's missing. Your equation will always be parts equal to your whole. And wherever that variable is wherever that variable is. I'm glad that you said that, because I want to make sure before your test that you guys understand that. It doesn't matter what information is missing. I could change this up, and I could say to you, okay, I have 3,000 flyers. I could give you the number of flyers. You could know how many in each, or flyers in each stack. And I might say, what's the number of stacks? This equation, this game plan is the same thing in this information relationship, no matter what is missing. Does that make sense to you guys? Awesome. All right. So now we're going to go ahead and write our equation. I don't know my total number of flyers, so there's my x. So yeah, this is the time that we're going to have x equals because the total is what's missing. All right. So my number of flyers per stack is 15. Times my number of stacks, which is 6, that's going to equal my x. And if I multiply this out, I should get 90 flyers. So remember, you have to state your answer as a sentence. So I would say the total number of flyers is 90, or 90 flyers, or there are a total of 90 flyers, something like that in a sentence. You guys cool with that? Awesome. I'm glad you guys asked for that one. All right, so let's take a look at number 44. Because you're definitely having story problems. All right, you're at least having one, perhaps two, no more, usually no more than usually two on these, because they take a little longer. All right, so let's take a look at number 41. 41 said that I have 2.8 minus a negative 4.7. Who asked me for 41? Okay, so this was just skills. There was nothing fancy going on here. They just wanted you to, it says perform the indicated operation. So they just wanted you to do this. So remember, anytime that I have subtraction, I always want you doing adding the opposite. Because when people look at this, they're like, oh, I have a positive number and a negative number. I have to do absolute value work, and then I have to subtract them. How many of you guys can see that that would definitely be a mistake somebody makes? Okay, that assessment can only be made when you have addition. So always change subtraction to addition and the number after to its opposite. And then we can see what we're really adding together. Here we're just adding two positive numbers. So I'm simply just going to add 4.7 and 2.8. That's 15, carry the 1, that's going to be a 7. I bring my decimal point straight down. Positive 7.5. Cameron, are you cool with that? Awesome. Let's take a look at number 43. You guys, I'm going to go quickly through these. If you have a question, please raise your hand and stop me. I want to try and get to as many as I can here. All right, so if I take a look at 43, same idea. It said 7 divided by a negative 2.5. What is the purpose of these parentheses? AJ, sit up, please, pay attention. What is the purpose of these parentheses? Because people see parentheses and they're like, oh, we have to simplify inside the parentheses. What's the purpose of these? Valentina? You can stop right there. You know it's a negative number. It just contains that negative. You don't lose the negative sign. All right? Are they necessary? In this expression, are they necessary? Amanda? No, they're not. But what I don't want to happen is I don't want this to happen. Can you guys see that that negative may get caught up in that division symbol? Right? But the moment I do this, you're like, oh gosh, that's right, that's a negative number. Only reason for that. Okay? So off to the side, I should see 7 divided by, drop the negative off. You don't need the signs, the negative signs on there. Once you get the answer with your division, then you're going to think about your signs. So I'm going to put a couple zeros on there. Remember, I have to move my decimal one place to the right, which means I'm moving my decimal one place to the right on my divisor and my dividend. Okay, well, 25 divides into 70. Well, 25 cents, if I multiply it by 3, that gives me 75 cents. So that's too big. So this has to be a 2. So that's going to be 50. I have 2, bring down that 0, 200. Well, there are 8 quarters in $2. So that's going to be 200. That's going to be 8. So my answer is a negative 2.8 because I'm dividing a positive and a negative number. That's all the work that I should see. Yeah, you guys, you have to pay attention to the order. 7 divided by 2. What would this look like if I wrote this right here with a fraction bar? What would this look like if I wrote it with a fraction bar? Patrick? How many of you guys agree with that? 2.5 over 7. Ooh, Alex, you're so quick to put your hand down. No. 7 divided by negative 2.5. Okay, so pay attention to the order. The order matters, okay? So the numerator, or the first number, is what goes inside your division symbol. The denominator, or the second number, is what you're dividing by. You guys cool? Yes. So you can't have a you cannot have a decimal in the divisor. So however many spaces you need to move that decimal over in the divisor, here I only needed to move it 1 space to the right. I moved the dividend the same amount, that decimal the same amount, and that's where the decimal remains. Okay? All right, let's take a look at 44. 44 said solve the equation, check your solution. So I have x plus 6 equals 1.8. Who asked me for this? Okay, so remember, anytime you have subtraction in equations, always change it to adding the opposite. Okay, I don't know what all of you guys are writing down. You're making sure you're on this, please. Okay? Anytime you have subtraction, always do adding the opposite. But if I have subtraction, you're not changing it. Okay? So, Valentina, what can I add? Because I always want addition. What can I add to a positive 6 to make it 0? Negative 6. So I'm going to add a negative 6 to both sides. Because I want this 6 and the negative 6 to cancel each other out. So I end up with x equals. I'm okay with you not having, in this class, I'm okay with you not having x plus 0 equals. Okay? You can if you want to. I'm not going to require that. Remind me that I said that. Just remind me I said that. Okay? So x is equal to, well, I'm adding two numbers with different signs. I have the bigger on the top already, so I don't need to rewrite this. I can go ahead and just do the subtraction. This is going to be a positive 1.2. 4.2. Wait. Hang on. I made the fatal error. I lined up my 6, and I shouldn't have. I had to remember that was 6 and not 0.6, but 6. That's my mistake. So now my order is, I need to make sure that I put the bigger minus the smaller. All right, so now I'm going to go ahead and do this subtraction. So 5 minus 1 is 4, 10 minus 8 is 2. So that's where that negative 4.2 came from. Thank you for paying attention to what I did. All right, that's it for the chapter review. Yes. 47 is a positive 8.3. Sure, absolutely. So it says u minus, oh, I'm glad you're asking me to do this. U minus 4.6 is equal to 3.7. So AJ, I would always, even for me now, I will do this a lot. I will do it most of the time. Always change subtraction to addition and the number after to its opposite. That one small thing, a lot of times, alleviates a lot of mistakes. All right, so I have u minus 4.6. I'm going to do plus a negative 4.6. That way I'm saying the same thing to myself every single time. I always have addition, and I'm always saying to myself, what can I add to that negative 4.6 to make it 0? So AJ, what can I add to my negative 4.6? Excellent. So I'm going to add a positive 4.6 to both sides. So my negative 4.6 and my positive 4.6 cancel each other out, and I get u equals, and now I'm just going to add these. 7 plus 6 is 13. Bring that decimal down, carry the 1, and that's going to be 8.3. That is such an easy mistake to make because this is a positive 4.6, isn't it? And what we do is we forget to do adding the opposite, but we still think that we still see this as a positive 4.6. So we think since this is a positive 4.6, I'm going to add a negative 4.6 to it. The problem is we forgot this was subtraction in front of it. So just getting in the habit always of adding the opposite will alleviate just that small mistake. Does that help you? Awesome. All right, so let's jump to that one story problem that you guys are mad at me for. All right, this is kind of like what your homework quiz was. All right, so I want to redo for you. This is page 82, number 37. All right, so they give us this drawing. It's really important that you're making sense of what you are doing before you do it. So they tell us that these are tomatoes, these are cucumbers, and this is a field. They tell us that this dimension here is x. This dimension here, so like the width of these fields, is 800 feet. And they tell us the length of the fields, or the other dimension of the fields, is 500 feet. Now, I'm not giving it to you part A, part B, part C. I'm simply going to say to you, the cost of growing tomatoes is 27 cents per square foot, and cucumbers, or cukes, of 10 cents per square foot. I want to write an equation for the total cost of planting the fields, planting both fields. It's a total cost. So it's together. It's all together. Okay, so this is my advice to you. We are always going to start with a very general game plan. There's a lot of stuff going on here. If I have cost per square foot for my tomatoes and cost per square foot of my cucumbers, what do I know I need to find about the cucumber field and about the tomato field if I have cost per square foot? Matthew? I need to know that I have area. How many of you guys recognize that I need that? Okay, so now what I'm going to do is I'm going to do a very general game plan, and then I'm going to break it down. I feel like that's a really good way to start, just to get an idea of in your brain what is, overall, what am I doing, and then think about the details. The moment you dive into details is the moment things start to get confusing. How many of you guys kind of have that happen to you? All right, so don't think details right now. Think big picture. So I'm going to say my total cost equals, and I might actually do more than one game plan. I'm just going to kind of break it down as I need to until I get my final one. It's worth the time. So it's going to be the cost of the tomato field plus the cost of the cucumber field. How many of you guys agree with that? Right? The total cost? Okay. So now let's think about how we find the total cost. Well, we know that we have a cost per square foot of the tomato field, and I have to multiply that by the number of square feet of the tomato field. How many of you guys agree with that? Questions on that? Are you guys good with that? Right? Because I find the cost per square foot, I multiply it by my number of square feet, that's my total cost. I'm going to add that to the cost per square foot of my cucumber field times the number of square feet of my cucumber field. I have done no numbers at all. All I'm doing is doing a common sense game plan. Start with the big picture, slowly work your way into details. Okay, now I'm going to go ahead and fill this in. How do I find, up here, I have area of a rectangle. How do I find the area of a rectangle? Sophia? It's my base times height, or my length times my width. I'm going to write that down because it's my formula that I'm going to be using to find the square footage. So now I'm going to go ahead and put my numbers in. Okay, so the tomatoes are 0.27 times. No, don't put units on these. Leave the dollar sign off. Yes. So how do I find the area of the tomato field then? 500 times X. How many of you guys see that? So let's go back up and see how she found that. Here's my tomato field. We know that the width of the tomato field, or the length, whatever you want to call this, is 500. We know the other dimension is our X. Danny, sit up. Okay, that's the easy one, right? That's a little bit easier. Now, the cost per square foot of my cucumber field is 0.10 times. How do I find the square footage of my cucumber field? Cameron? 500 times 800. Let's take a look at that again. So here is my cucumber field right here. So I need this dimension right here of it, Cameron, don't I? Is this 800? So what is this? Go ahead. Not Y, this is an X. That's okay. It's my handwriting, not you. 800 minus X. How many of you guys see that? How many of you guys took the time to write that dimension on your drawing? Write the dimension on your drawing. Help yourselves out here. Go back to that dimension. Write it, go in there. Label this entire drawing so it helps you. The more details you give to this drawing, the more it's going to help you. Yes. Maybe, yeah. Okay, so now it's going to be 500. So I'm going to multiply. So this is 500. I'm going to do a big bracket here because I have to do I have to do parentheses in here as well. So 500 times the quantity of 800 minus X. I have to multiply that. This is that area of the cucumber field. I think that's the hardest part. But going up to your drawing and labeling that will be very helpful if I give you something like this. And now you're just going to do the distributive property to solve for this. Okay? And then I may say if that X is equal to 200, once you've simplified the expression, then you're going to put the 200 in. You guys cool with that? This, I think, is the hardest part. But how many of you, when I wrote that very general game plan, it made it a little bit easier to do the specific one? Please do that. Get a very basic idea of what you need and then detail it. Yes, Amanda? It's a great question. No. You can mark it up from there. A drawing that I give you, a shape that I give you, that is yours to use any way you want. The only thing you need to rewrite is this stuff from the game plan, right? Or from the information. You don't have to redraw that. Okay, let me move on. Okay, if I take a look at, you need to let me finish up here, okay? Because I have very little time and I want to get to many as I can. Okay, if I look at worksheet 2.2b. All right, if there's anything I don't get to, I am here for lunch. Come see me if you'd like to, or study hall. All right, we asked for number 15, and you guys asked for it or something with fractions. Okay, so if I have number 15, this one came from the advanced math book, so these were a little bit harder, weren't they? All right, with those fractions. All right, but let's remember, if my coefficient is a fraction, all right, I am just going to multiply by its reciprocal. So if I multiply negative 3/4 by 4 over negative 3, and I do that to both sides, what happens to my negative 3/4 and my negative 4/3? What happens to them? Cameron? They cancel out, and I'm just left with a 1, which is what I wanted. And then on the other side, I'm just going to divide out common factors, DOCF. The 3 becomes a 1, the 12 becomes a 4. So my final answer is 16. On your test, do this next to this. On your test, I might give you that, but I also might give you something like x over negative 4 equals 12. What am I going to do to solve this? What am I going to do to solve this if it looks like that? Sophia? Yes, I'm going to multiply both sides by a negative 4, so keep that in mind. So if I'm writing something down as an additional example, I highly recommend that you're writing it down. You're not just sitting there looking, all of you. AJ, that's you, and Danny too. I suggest you're writing this stuff down if I'm giving you extra examples. All right, if I look at 19. All right, 19 gave us this rectangle. They gave us x and then 10 inches, and they told us that the area was 70 inches squared. It says the rectangle has that area, write and solve the equation to find for x. Well, we already talked about the area of a rectangle is base times height. So I'm just going to substitute in what I know. I know my area is 70. I know that my base is 10 and my height is x. And then I would just solve that from there. With a triangle, how do I find the area of a triangle? These are ones I expect you to know. How do I find the area of a triangle? Danny? Yep, so 1/2 base times height. All right, trying to go through these as fast as I can so I can get to everything. Worksheet 3.5. Does anyone have worksheet 3.5 on them? So, thank you, Alex. Don't let me forget to give it back to you. So, you guys asked me for number 24. So, Valentina, who asked me for this? Who asked me for 3.5 or 3.6? Okay, so is it the one with multiplication or addition that you're looking for? Is it the story? Is it the one with the words? Okay. 3.6? Okay. So this is worksheet 3.6, number 24. So it says the product of some number n and negative 0.26 equals 169.39. And it says find n. All right, this is a math sentence that's like a game plan, so we need to kind of decode it. What operation goes with product? What operation goes with product? Alex? Multiplication. You guys, everyone look over here at me. You do know I give you a grade for participation, right? So even though if you're sitting there and you're like, I don't need any of this review because I know what I'm doing and I don't need any help and I got all these right, then share. Because you are graded on participation in my class. All right, that means you're raising your hand to answer questions when you know the answer to them. If you're shy enough and you don't want to raise your hand if you're afraid that you're going to look wrong because you get something wrong. All right, but do you know how many times I've been wrong? A ton. Okay, I want you guys being wrong. Ada said, I did it the wrong way. Can you help me? And thank God she said that because I forget to point those things out to you. I need to know when you guys make mistakes. So all of you need to raise your hand and be opening your mouths, please. Okay, product means multiplication. All right, it's the multiplication of some number and 0.26 because here's my equal sign. So if I was to write this out, I'd have n times a negative 0.26 equals 169.39, or I could have written negative 0.26 times n is equal to 169.39. Either one of those are fine with me, and then you would do that division. Does that help you guys? Okay, so Alex, let me give this back to you because I think I did all of them from that one. Thank you, sweetie. I think the only thing I have not done is page 99, number 26. So let's dive onto that. Okay, so if I take a look at page 99, number 26. 26 said a type of thermal ice drill can drill through ice at a rate of 15 feet per minute. So we have an ice drill, 15 feet per minute through ice. All right. You guys, when you're writing your givens down, just bullet point it like I am. You don't need to rewrite everything. Save the space for your work. All right, so I'm just going to bullet point stuff. So that's information I know. Find the time it takes the drill to melt through a sheet of 75 feet thick. So we have 75 feet thick ice. How long to drill through? Colin, did you ask me for this? I feel like it was you that. Sophia, was it you? Okay, I knew it was someone over there. What kind of number is that? What kind of number is that? AJ? That's a rate. I'm going to write that down. Feet, feet per minute. What operation do I always use with a rate? Amanda? Multiplication. What information do I always know I'm going to multiply that rate by? Colin? Which is? Number of minutes. When I do that multiplication, what information does it give me? Or, what is my whole? Ada? Excellent. Can you guys see how I did that? All I needed was my rate. I didn't even look at any of the information they gave me other than the fact that they talked about rate and we're talking about total thickness. No numbers. That's how I did my game plan. And if you automatically know your rate is a part, I guarantee you, and you recognize you have to multiply it by the denominator information, you will get those game plans right. Okay? So now, what I don't know my time. So there's my x. So it doesn't matter which piece of information is missing. I could have said to you, it took me 5 minutes to go through however many thickness, what was the rate per minute? And this is still my game plan. Can you guys see that? All right, so now I'm going to put my numbers in. So I have 15x is equal to 75. And then I would solve that. Sophia, does that help you? Awesome. Okay, if you guys have any other questions, please come see me at lunch or at study hall. Let me know if you're coming at lunch, just because I can make sure that I'm sitting here. All right, you guys good to go? All right, when you come in on Monday, I want you to immediately